Bluetooth for high-end part 2. Let's have some hands-on on different devices and test, listen and measure performance of those devices. Okay, I did some investments and bought from AliExpress different latest generation Bluetooth devices. All of them has a Qualcomm chip inside, and quality is defined by Qualcomm chip. And the key differences are how the output circuits are made, but functionality is pretty similar. This will be my transmitter, because here I can select what kind of standard I'm using, and I will use it for subjective listening, find out how large is the impact of compression and how good is a high definition, how good are aptX, and of course standard codec SBC. Adaptive, it depends also from receiver. This is interesting device, because for me it's very difficult to position it. It is like a transmitter and receiver, but it's large. For a mobile applications or use for some non-Bluetooth headsets conversion to Bluetooth headset, not exactly. But it is good as a transmitter, I would say. I would position it that it is excellent transmitter for a budget, because if you want to buy another one, larger one, or with larger external antenna, then the price is double and triple in frame of 20 euros, including shipping. I bought 2 of them, also test it as a receiver and play around with those devices. Then here is, in my opinion, great device if you want to convert non-Bluetooth headsets to Bluetooth. Due to the small size, you can see you can put it in a pocket, and it really has a long operation life. You can 40 hours, I think you can use it for 40 hours, for 2 days full-time listening. Excellent small device and accepts all standards, including HD. Then there is one more which I bought. This accepts only one standard. It accepts SBC standard only, but it has DSP inside, and I was curious what the DSP is doing and how does it sound. Also, it has Class D output amplifier. Those has some another technology. Also, it could be used as a transmitter and as a receiver. Budget device, but very well built, and it has also a remote control where you can set some additional functionalities for DSP. And then 2 devices which could be used as a link. They have external digital to analog converter, which we discussed in a part 1, and this is meant for no kind of digital link. Then this goes into amplifier, and then you do another thing. So, for example, this device is optimized for headphones, and this one for linearity. And this device supports LDAC, but I don't have LDAC transmitter. Maybe I buy it later on, so I will not do experiments with LDAC. What else do we need for experiments? We need something for subjective listening, and I have relatively good and expensive Sennheiser headsets, 100 ohms. So each of those devices will be able to handle. Typically, they are able to handle from 16 to 32, but 100 is okay as well. So there shouldn't be problem. No, maybe with volume, but shouldn't be problem to drive those headsets. Then I have professional high-resolution headsets, but I need external preamplifier to really drive them, because otherwise they will sound kind of sharp or not sufficient bass. And I will do some experiments using external preamplifier with those. Those has extreme resolutions, also studio recording headsets, AKG K271, and there I will try to hear and listen difference between compressed and uncompressed or non-compressed audios. You can't use room audio system for that. Is not sufficient resolution to constantly really to find out compressed and uncompressed signal quality difference. Those are so tiny, you have too many subjective things to find out. We should minimize number of equipment in a series, and so we will listen them directly. Actually, I ordered one device when I can add several headsets in the same time, and then I can listen of them, but I'm waiting until it comes. And then I have one more. Those are Sony headsets, MDR RF 6500. Those are obsolete, but those used to be very good and expensive headsets for home cinema, and they have exceptional resolution and super high tolerance. Even having additional analog to digital conversion, then digital to analog, those using the digital link, but all components are so good that there is no quality losses. Those are very precise when you do listening. There are base station, where the signal is formed. You can see pretty large, and you can charge. I will also listen on those high resolution Sony headsets, because those are giving a really objective feeling how it will sound in a room. One more thing to be considered. I need really a high quality source to hear a difference. Here I have special selection of external hard drive for audiophile-grade music, audiophile tests, and I collected several music information from Macintosh equipment, which are provided along with them to really do the test recordings. But I found out that Bower and Wilkins really provided 5 pieces, exceptionally good recordings. To hear difference between compressed and non-compressed, you need a specific music. Actually, you need a music where there are 3 layers. Otherwise, it's not possible to hear it. You need a music with a dominant voice, and then a little bit background instruments, and then back vocal, what is below, and also some instruments. When you have 3 layers, it's very difficult to compress. You should provide all details, and if you are not, then immediately you can hear it. So your recording, when you're compressing, doesn't matter which kind of lossy algorithms, then it become kind of cleaner. It's not bad, it's still good, but it become kind of cleaner. So you are losing those super small details. Very hard to hear. With MP3, it's almost impossible to hear because those algorithms are so sophisticated. But algorithms like SBC or low latency or even aptX, those are not that processor powerful, and then compression are a bit simplified. So with Bluetooth, you can hear if you use right music. And you need good headphones and good output amplifier from your Bluetooth device. So many things you need to hear it. And then we can make more or less correct conclusions. And one more thing, which I will not show how I measure or I did, but I find out that this Qualcomm chip has very good analog to digital converter. And if I put analog signal in and do this analog to digital conversion and send it via the air to receiver, I was not able to recognize difference. That means we can do measurement signals using arbitrary generator, and it's a good thing that there is no quality losses from analog to digital conversion. So the Qualcomm chip is kind of champ, real champ, and this development, what happens in the last 3 years, are tremendous. So what I will do, I will put oscilloscope and then measure different pattern signals and output linearity of those devices. And after that, I will summarize subjective listening, which I will not show there, but share my experience. Now let's measure. Okay, we will do standard measurements. Here is our reference signal generator or arbitrary generator. Signal from arbitrary generator is going to both channels in transmitter. This is our reference setup, and on transmitter I will change different standards, and we will watch out what will happen on oscilloscope. and we will start to measure this sibling of transmitter and then check what manufacturers are doing to get the best sound out of it. So, those are positioned as a headphone amplifiers. They have their own power supply. For those which need external power, I prepared high quality power cable. It's important that it should be shielded, and those will be fed from USB, good power supply. When I mention good, that it's important because sometimes you get noise from them that is not possible to filter out even at the board level. You need to somehow provide high quality power, no standard power, but use high quality components. Some of components what's coming with the boards are really bad. I would say they are not providing components. Just yes, you can put it together, but if you want to high fidelity sound, then you should think about it. Okay, the first unit for measurement will be this unit, the same as transmitter. Okay, switch it off, on, and now it's connected. So nice, great, clean signal. And the first things always to measure what is happening with the frequency characteristics, because for headphone preamplifiers, those manufacturers often cheating. I will put a sweep 20 to 20 with external synchronization, and here we have somehow looks kind of okay. Even no drop of the high frequencies, but there is always problem with the low frequencies. And let's check really what is the lowest frequencies what this particular device can provide. Add on to frequencies, still down. It's already 600 Hertz, still down. And here is a 1 kilohertz, we have 0.9, and practically starting from, I would say 600, 500 hertz, yeah, we are dropping low frequencies. When I tested really with the headphones, they sound thin, there's no low frequencies, kind of emphasizing the high frequencies. And I would say this is very bad bandwidth. As a headphone amplifier, it's not working, I would say. There is no signal at 20 Hz at all. About 50, you have 10%, not 20% from initial signal. And at 100 Hz, 30% from initial signal. Not very bad, no very bad. So low frequencies are not presented at all. Why it is done? Maybe it is this device is for web conferencing when you use almost telephony, I don't know. But this is what that measurements are showing, and also I can hear it in the same way. So practically frequencies are cut from 500 Hertz. I have no comments. When I put the headphones, they sound flat. Yeah, definitely you can't use at the line input or input for amplifier. Even for a headphone usage, I'm not happy with that. So this device is for transmission. Because on transmitter it's perfect. For that money it's great, absolutely great. But if someone would ask why designers made it in this way, I have no clue. And how about high definition? We're going down, 100 Hertz. It's the same. So this is a problem with output circuits. Clearly problem with output circuits. Those are filtered, low frequencies are filtered out. Yeah, we can only guess what is the purpose of this board. But it's good as a transmitter. It's not good as a receiver, but as a transmitter it's perfect. Now let's measure this small one with the same functionality as a larger one. And we will start with SBC as before. Let's check a lower region as we are on the same settings. So here we have 1 kilohertz. At 1 kilohertz we have 500 millivolts for the same input signal. Let's remember this 550, and let's go down. And you can see at 100 hertz the same, 550 millivolts. How about 50 hertz? excellent. How about 30? Almost there. And about 20, minor drop, a neglectable drop, I would say. Speakers has much higher. So lower end is absolutely perfect. How about a frequency range? Let's make a sweep. And here is a sweep. And you can see this is clearly optimized for headsets, for headphones. Because this particular headphone receiver is trying to simulate kind of room, and in room we have more bass and a little bit less high frequencies. And I would say when I listened with the headphones, absolutely excellent performance. This is how it should be for a good headphone Bluetooth. And those drops on a high frequency, those are neglectable because overall it sounds good and precise, like in a room. So, but definitely you can't use it as a line input. Yeah, that's no way. If we go for high definition, now we have a high definition standard. We have broader bandwidth, and it seems like a little bit more noise. But anyway, it's absolutely the same pattern, the same. There are more details, the wider bandwidth. This is right picture. And if you look at 1 kilohertz, absolutely excellent signal. Absolutely excellent. How about the square? No, almost perfect. Yeah, almost perfect. All around, that small device performs fantastic. And now let's test this well-built wireless music. It has only SBC codec. And let's check characteristics. It also has a Class D output circuits. Pretty powerful. Here we are. Signal is larger, but anyway, clean and great at 1 kilohertz. We can filter out those Class D modulation frequencies or subcarrier frequencies. No, modulation frequencies. I have 10 kilohertz filter. Let's put it. Yeah, absolutely clean, perfect, nice signal. I will put it back. Because we want to measure different bandwidths. And here is 20 to 20 sweep, and this particular device has very good output amplifier, and it can go up to 20 kilohertz. Let's check lower and upper frequencies. No, at 1 kilohertz we have 0.7 volts. How about 100 hertz? A little emphasizes to the low frequencies, 0.75, but it's practically inaudible. How about 50 hertz? The same as 1 kilohertz. How about 30 hertz? Excellent. About 20. Yeah, at 20 we have a drop, but who cares about the 20 hertz? If the 30 hertz is fine, this is tremendous device. Because at 20 hertz there is no music anymore. As most of speakers what we have at home, those are not capable to produce 20 hertz. Those are below resonant frequencies of the speakers. And how about 16 kilohertz? You can see signals input and output are not in sync. They don't have the same clock, but it's not important. So 0.7, excellent 16 kilohertz. And how about 18? It's the same. And 20, almost the same. This is a fantastic result, I would say. Fantastic result. Unexpected. But of course you have all drawbacks based on this SBC codec, and it will lose details, but output amplifier is built for that device. Fantastic, and it sounds good. It has DSP in it, and I will give some comments later on about the DSP as well, how it subjectively sounds. But output amplifier is fantastic. And now let's check those two last boards, which are not for the headphone amplifiers, which are more for audio link to some amplifier. So they should have a linear frequency characteristics and the best performance. They have this separate or dedicated output digital analog converter, and it could support, I think, also 24-bit format, at least by the noise level, what is mentioned in specs. So this is different board for a different purpose. It doesn't have onboard battery. You should provide some power for that. And let's check, could we use it as a wireless link between your phone and amplifier. And what we can see, we have double output signal comparing those battery driven. This dedicated chip and technology what is there allowed to have significant output level, and it's important to directly drive amplified stage if you need, because we have the same input level for all tests. I'm not changing them, but you can see the output level is 1.38 volts, and the last one what we checked that has 0.7. Yeah. So almost double output. Signal is excellent, and let's check sweep, and we can see that it is flat, but top something above 16 kilohertz. For me it seems that they are a little bit dropping for a decibel or two, and let's check those frequencies. Just for curiosity, how about the square? Square is great. I guess, I'm not sure that those outputs are meant for 600 ohms resistant. Then you will have the same perfection as on a top. But otherwise, absolutely great performance. And first, let's check low frequencies, starting from 100 Hertz. Let's remember this 1 kilohertz reading, 1.38. And how about 100 Hertz? Flat, perfect, the same, 138. How about 50 Hertz? The same. Okay, 30 Hertz, no minor drop on 30. And okay, 25 Hertz, we have slight drop on 20 Hertz. It's performing very well at low frequencies, which is important for stationary operation or feeding amplifier. And this is all about that dedicated digital analog converter circuits. And now let's look at the upper region on starting from 15 kilohertz, 1.4, 15 perfect, 16 perfect, 18. No, microscopic drop, but practically 18 is a perfect. On a 20 kilohertz we have significant drop, about 3 decibels. So normally we can work about 18 kilohertz, but this is fantastic result. 18 kilohertz is very good. Normally we don't need 20. If we can work up to 18 kilohertz, majority of people, aging people, doesn't care about 12 kilohertz. 16 kilohertz is great even for young people, and there is no music after 16 kilohertz. But we have a great bandwidth provided by this technology. And last one to be tested, this. At least I bought that device. It has different chipsets, and it can also work with a LDAC standard. Let's check what this board or what this small device can. All of them below 20 euros, including shipping, between 12 and 17 euros, which I bought. Because this previous board, it performs absolutely great. It's fantastic. It's almost hard to find arguments why to go for something better. And okay, we are at 1 kilohertz, and I said this board has a different chipset at output. And the first difference is that output signal, instead of 1.4 what we had for a previous board, has a 1 volt at output. This board is set kind of 1-to-1. The same what I'm providing at input, we are getting at output. It is kind of better calibrated, and I like such pattern. Then you have everything predictable, but it's not a key differentiator. Signal is nice, great, and clean. Let's make it a little bit larger. And the first look to bandwidth. I will put a sweep, and you can see it has the same pattern. Very clean signal, and slight drop at 20 kilohertz. But let's check details. But overall, it is fantastic frequency characteristics. I'm surprised. How about the square? Square is nice. It has some high frequency emphasis. Okay, let's check 100 Hertz. The same reading. 50 Hertz. Oh, slight, but it's in frame of readings. Maybe microscopic drop at 50 Hertz. 30 Hertz. No, very minor drop. We can say that it's flat. And at 20 Hertz. And at 20 Hertz we have some drops, but I would say this particular small board is even going down to 20 Hertz. Very good reading, very good output amplifiers. So chips which are used in that small box are good ones. And how about a higher region? Let's put some 15 kilohertz. Microscopic add-on. But we can count it as a flat. It's not. We will not hear it. Yeah, there was 1 point. No, it's the same. 1.8, practically flat. At 18 kilohertz. No, let's check at 18. Yeah. Then from 18 we have some starting small drop, but up to 16 it's absolutely flat, and after 16 we have some minor drops. And at 20 kilohertz, there are some drops. So we can say that this particular board is flat up to 16 kilohertz, usable up to 18 kilohertz, and then after 18 kilohertz they have some small drop. But it is very good result. Taking all complexity of the technology, it's a fantastic result. Yeah. I'm still guessing, is it at a digital part, or it is this analog digital converter what comes through the Qualcomm chip. You can see the small chip is providing so much quality. I'm impressed. And looking at full bandwidth, you can see everything what I told. Here up to 16 kilohertz it's flat, then somewhere at 18 it starts to drop, and the last moment up to 20 kilohertz, then we have a small drop. But this is fantastic result. It is absolutely excellent. And are there any changes if we put at a high definition mode? And now I put in a high definition mode, and what is the difference? You can see that this signal doesn't look that stereo as it is in SBC codec. So, and this is a good sign because you can provide more details in that case. So high definition mode also, but there is no noise. It's a perfect stereo signal. If you put continuous sine wave, is the same clean and stereo signal what comes out from those boards. Actually, the quality, general quality is very good. Yeah, we can discuss about those 20 kilohertz, but from the listening perspective, there is no difference. I'm really happy with the measurements and how they perform. Come on, below 20 euros, those are basic devices, and how about the good ones? And those basic devices are already exceeding all necessity what we have. Now I will do plenty of listening tests and give some subjective feeling about things. After the measurements we can do some better interpretation what we will hear. Okay, and some summary about the hardware check. This Bluetooth design, it's a good transmitter. But I think there is even better ones with antenna if you want to use them stationary. For me, it's really hard to position, and the biggest disappointment was at receiver mode. There is some problem with output circuits. Those are limited at low frequencies, and honestly, Due to the price, you can use it as a transmitter, and it really works well. Also, when you put a USB cable and connect to our desktop computer, it is working like a sound card, becoming default device, and you can start to stream through the Bluetooth music. But overall, headphone performance so-so. So I have two transmitters. I will use them as a transmitters, but generally, would I recommend it for transmission? Yes, but I think in the nearest future there will be better devices or some version 1-to-1. Not ready yet. This one, very good device, especially when you want to convert your headphones in a Bluetooth headphones, and in some sense this is better solution than built-in Bluetooth in a headset or a headphones, because this technology is developing, and 50 hours of operation, few bucks for that, very well built, very well performing. The Qualcomm chip is fantastic, and the hardware wise it's also, when you put it and listen, it's really good, and it accepts all standards including HD standard, and HD standard is important for Spotify because Spotify has a compressed source when you buy a service, and then you need uncompressed to not lose the quality, and then in HD mode it works very well. Of course, you need some source or phone with a HD operation option built in, but otherwise this is almost excellent device if you want to convert wired phones to Bluetooth phones. And output amplifier is optimized for a room type of listening. It's not flat, it's rich, and there's a high frequencies and low frequencies. Definitely you can't use it as a link or a line input, but for a headphone, fantastic device. I would especially mention this device. This has only SBC format, and I can't use it for Spotify because the losses are well presented and I hear it. It has digital processing, and for example for audiobooks or for speech or for listening news and YouTube, not high fidelity audio, it has fantastic performance. It has Class D output amplifier, the minimum amplification consumption losses. It works for a long time, very well built, and even not for high fidelity audio, I'm impressed about the quality of what modern DSP can make. And those DSP somehow expand that mid-range. It becomes so good and so good clarity of the speech and voice that I'm counting this as a good device. For example, for this device, I'm generous when evaluating the 10 points for a purpose what is built, and this also 10 points. It has relatively heavy enclosure, but good device. And those two which are used for high quality audio transmission, having slimpest signal chain like a phone or a tablet or other Android device, and transmit signal to amplifier, excellent performance, very low noise floor, and so many good things when you do everything right, that for me it's even hard to find the proof to go for higher quality device. This is 15 euros, and if you want a next step, which you maybe even don't hear, there's a 250 euros minimum. Yeah, in that case, maybe you have some improvement. Actually, if you put everything right, then the quality, this transmission link quality is fantastic. And dedicated digital tonal converter also solves a lot of problems. And this device has almost the same architecture, but has one important add-on, there is a hum eliminator, or when you put 5 volts from USB input, which could be noisy, and often it is noisy, especially for mainstream computers, there is a special device which is separating input power from output. There is a converter and transformer in one chip, not a chip, in one small box, and then you're solving that potential hum or potential high frequency noise out of it, and it's become really a universal device. You can fade it from anywhere from the bad power supply, and it's important step up, because there are so many bad power supplies that we should deal with them. And regarding audio quality, of course we can complain that there is no 20 to 20 kilohertz or something, but my personal judgment is that today Bluetooth technology is high-end ready. From listening point of view, everything is okay. Quality is not an issue, but of course you should use high definition codec only for high-end listening. You can't use any lossy codecs which are here. Those are not the MP3 codecs. Those are they're far simpler, and you can hear that high fidelity components are missing for SBC codec, for aptX standard codec, for low latency codec. Only this HD codec is capable to transmit all details necessary for high fidelity audio. And then I can't hear a difference from the source. It's the same. For me, it's the same. Even listening with high resolution headsets, I'm happy. But with high resolution headsets, I can immediately recognize those low bandwidth simplified codecs. And when you're transcoding something to those SBC or aptX standard codecs, you immediately hear quality degradation. So I didn't made any listening tests with LDAC or LDAC. Maybe someday. I don't have a good transmitter. My final judgment is that Bluetooth is ready for high-end. I know that there will be tons of people who will not agree with me, but let's be pragmatic. If you're really listening to music, then HD aptX codec is great, and this technology rapidly developed to the really acceptable level, at least for me. I'm kind of picky guy.